Good morning, class, and welcome to chapter 3 of our computer hardware class. This is supporting processors and upgrading memory. Types and characteristics of processors. Processors are installed at motherboards and determine system computing power, which is, right, the processor is the CPU. Two major processors manufacturer, Intel and AMD. There's others that make it, but these are the main ones. Features affecting processor performance and compatibility with motherboards, processor speed, lithography, socket and chipsets the processor can use, multi-processing abilities, multi-processing, multi-threading, multi-core processing, dual processing. You see it when you see multi-core when you do virtualization. Features affecting processors performance and compatibility with motherboards, memory cache, memory features on the motherboard that the processor can support, support for virtualization, right? That's very important. Integrated graphics, that's your motherboard, that's your video card, and overclocking. We talked about overclocking a little bit. Overclocking is used for gamers who want to set it up a little bit faster, their CPUs. But what happens with overclocking, right? It will get the whole unit hot. So if you're doing overclocking, which I don't suggest you do, but if you do, make sure you use liquid cooling, right, to cool it down. Today's processor architectures falls into two categories. Hybrid processors known as the x86-64 processors, which can handle 32 or 64-bit OS, which is OS's operating system, or 64-bit processors known as x64 or IA64, requires a 64-bit OS and can handle 32-bit by simultaneous 32-bit processing. Most of us have 64 nowadays. Here's the types and characteristics of processors, right? Here's the quad core, which means 4 different CPUs. Current families of processors for desktop and laptop include the Intel Core processors, the Core 9 and the Core i7 are made for high-end desktops and laptops. The Core i5 are well suited for mainstream desktops and laptops. And the 3 is an entry-level processors for desktops and laptops. The Pentium processors are designed for entry-level desktops and laptops. The Atom processor made for low-end, and the Celeron made for low-end notebooks and laptops. Some Intel mobile processors are packaged in Centrino processor technology. The Intel processor, chipset, and wireless network adapter are all connected as a unit. Intel dominates the market for servers with highly stable and powerful processors. Models of the Core 9, 7, 5, and 3 are designed for server use. High-end server, Intel offers the Xeon Phi, and Intium processors. AMD processors by AMD are popular by game and hobbyist markets. They're generally less expensive. Current AMD processors include for desktops, the Ryzen Pro, the Ryzen Threadripper, etc. For laptops, there's those, and servers. Those AMDs are usually a lot cheaper than Intel. And here's the processor. A hardware technician is sometimes called to assemble a computer from parts, exchange a faulty processor, add a processor, upgrade an existing processor. In each situation, it's necessary to know how to match a processor to the system and install a processor on the motherboard. First requirement, select a processor that the motherboard is designed to support. Where do you get that information from? The manufacturer's website, usually, of the motherboard. Next, select the best processor, meeting general system requirements that the user needs. Processor features to consider: use the highest performing processor the board supports, understands the processor's ability to do multitasking, balance the performance and the power of the CPU with that of the entire system. Remember, all those parts have wattage, so you got to make sure you don't go over the wattage of your power supply. Also, read reviews of the processor you're considering and look for reviews that include comparison benchmark of several processors. Not only look at like people who write about them, reviews, look for customer reviews too. That I will give you a good sense if it's a good processor or not. When processors and coolers are boxed together, the cooler heatsink might have a thermal compound already applied to the bottom. This is pre-applied thermal compound right here. It's like a paste that you put, and then you hook this up. You put this on the CPU, right? And that should cool it. That makes it cooler. Always read the motherboard user's guide and then follow the directions. General procedures for installing an Intel processor. Again, use ESD strap or anti-static gloves. When replacing a processor, you power down the system, unplug the power cord, press the power button to drain the system of power, and open the case. Now, you might think pressing the power button to drain the power system of power is like maybe nonsense and be like, well, who really does that? Well, I recently got memory upgrade for my computer when we went over to a distant learning, and when I first put it on, the machine would turn on and right away shut off. And when I called Dell for tech support, the guy had me do that. And once I did that and I turned it back on, it worked. So yeah, sometimes it's a good idea to do that. Remove the socket protective cover. Open the socket by pushing down on the socket lever and gently push away from the socket to lift the lever. As you lift the lever, the socket load paste is raised. Remove the protective cover from the processor and hold processor with index finger and thumb and align processors so the two notches on the edge of the processors line up with the post embedded on the socket. Ensure the processors align correctly in the socket. Push down on the lever and gently return to its locked position. The lever is called the zip. Remember we talked about that last week, the zero insertion force. So here it is. Right here, the lever is here. That's the zero insertion force right there. So you lift the socket to expose processor socket. You put it in there, match the two posts match up with the two notches. You plop it in there, and then you close it. And then with this, it locks it in place. This right here. General steps for a cooling assembly. Understand how the cooling post works. Apply the thermal compound first. If necessary, it may be pre-applied. But if not, you put it. Some heavy coolers provide a plate that fits underneath the motherboard. Install the plate if provided. After the plate is installed, install the cover on top of the processor. For lighter coolers with locking pins, verify the pins are turned counterclockwise as far as they go. Push down on each locking pin until it pops into the hole. Connect the power cord from the cooler fan to the motherboard. Check BIOS UEFI setup to verify the system is recognized. The processor after the system's up and running. So here, that's a little bit of thermal paste. You just only need a little bit, right? I've seen that they put thermal paste like they're putting butter on bread. Don't do that. You don't need to put a lot of it, a lot of thermal paste. All right, just a little dab, because remember, once the fan goes on it, it kind of spreads out. So you don't need a lot. A cooler assembly plate at the bottom of the motherboard prevents a heavy cooler from bending the board. And then the fans are turned on clockwise to secure the cooler to the motherboard. Then you connect the fan to the 4-pin CPU fan on the motherboard. And then you go to the BIOS UEFI to verify. Installing an AMD, open the socket lever, remove the protective cover, orient the 4 empty pin positions on the bottom with the 4 filled hole positions in the socket, and carefully place processors in the socket. Verify the processor's pins are sitting slightly into the holes. Press the lever down and gently into the position. Apply the thermal paste. Install the cooler. Clip into the clipping mechanism on one side of the cooler and connect the fan to the power connector. Basically almost the same way as before. Right? Clips on the cooler. Right there. Right? You put the clips there. Replacing the processor in a laptop, a little bit more difficult. Before replacing, consider the laptop might still be under warranty, or it might cost more. It might be more cost effective to replace the laptop than replacing the processors. Remember, a lot of the laptops, they're, especially the cheaper ones, they're not that expensive. So keep that in mind. Like the $200-300 laptops, is it worth it to replace a processor? Probably not. If you decide to replace, use the CPU supported by the manufacturers and notebook model. For some laptops, remove the cover on the bottom to expose the processor fan and heatsink. Remove the 7 screws and the fan power connector. Lift the CPU straight up from the socket without bending the CPU pins. Before placing the new processor into the socket, be sure the socket screw is in the open position. Place the processor into the socket. Use thermal compound on top of the processor. There it is. That's the processor fan, the heatsink right here. The 7 screws secure the fan and the heatsink. Right? And there it is. Random access memory temporarily holds data and instructions used by CPU. You have your dynamic DRAM, loses its data rapidly, and the memory controller must refresh it several times, 1,000 times a second. Variations of DRAM. DIMM, dual inline memory module, are used by desktops, and SODIMMs are used by laptops. Right? So if you want to buy more memory for your laptop, it's a SODIMM. And for your computer, it's DIMM. Evolving memory technology results in many different details and opinions. Right, here's the different prices. DIMM and SODIMM technologies. The D in DIMM stands for dual, named for independent pins on both sides of the module's edge connector. All DIMMs have 64 data path. SIMM, single inline memory module, is an older technology that has pins only on one side. DDR, double data rate DIMM, twice as fast as the earlier DIMMs when it was invented. DDR2 SDRAM, faster than DRAM and uses less power. DDR3, faster than DDR2 and uses less power. DDR2 and 3 use 240 pins. Not compatible though, they use different notches. So what does that mean? You cannot have a DDR2 and a DDR3 in the same computer. DDR4 is faster and uses less power than a DDR3, uses 288 pins, and has a single notch in the edge connector. Factors that affect capacity, features, and performance of DIMMs: number of channels that they use, how much RAM is on one DIMM, speed, error checking abilities, and buffering. Single, dual, triple, and quad channels. Every single channel DIMMs. Memory controllers access one DIMM at a time. Dual channels, memory controller communicates with 2 DIMMs at the same time and doubles the speed of memory access. Triple channel, memories can access 3 DIMMs at once. Quad, of course, is 4. So DDR, DDR2, 3, and 4 DIMMs use dual channels. DDR3 DIMMs can use triple channels. DDR3 and 4 can use quad. For dual, triple, or quad channels to work, the motherboard and the DIMM must support the technology. Of course, you look at the motherboard's manufacturers, typically color code, in the website. Typically color codes DIMMs to show you how to configure dual, triple, or quad. Set up channeling. Pair of DIMMs in a channel must be equally matched with speed and feature. Right? For example, I bought this computer. I didn't buy a lot of memory, 16 gigs. I have 4 slots, right? So I had 2 8 gigs. I think I had a black and a blue. So I have, in the computer, I have 4 slots for memory. Black, blue, black, blue. So I had the 8 gigs on one blue and the other 8 gigs on the other blue. And then when I got the 16, and I bought 2 16 gigs of DIMMs. So then I had to put the other one in the black slot and the other one in the other black slot. Like, you can't do a 16 gig in one black slot and an 8 gig in another black slot. Can't do that. It doesn't like that. His using dual channels, the memory controller can read from two DIMMs at the same time. See how it is? Black slot, gray slot, black slot, gray slot. If you put one here, the other one you have to put here, right? If you're only using two, or if you're using like a 8 gig and a 16 gig pairs, so you put the one 8 gig here, you got to put the other 8 gig here. You put the one 16 here, you put the other 16 here. You can't put one 8 here and one 16 here. It won't work. DIMM and SOLDIMM technologies, matching pairs of DIMMs installed in 4 DIMM slots that support dual channeling. 3 identical DDR DIMMs installed in triple channel configuration. Expect a motherboard that uses quad channels to have 8 memory slots. The 8 DIMM slots support 4 channels. Each channel has 2 slots. The processor can address 4 slots or 4 channels at the same time. To know which of the 8 slots to populate for optimal performance, again, see the motherboard's manual, which is usually on the website, right? The Gigabit AMD X399 gaming motherboard has 8 DIMM, DDR4 slots, and supports quad channeling. This is why gamers like this. Look at this. This is a gamer's dream. DIMM speed are measured in megahertz and PC rating. PC rating is a measure of total bandwidth of data moving between the modules and the CPU. To calculate the PC rating for DDR4 DIMM, multiply the speed by 8 because the DIMM has an 8 byte or 64-bit data path. For example, a DDR4 runs at 3000 megahertz times 8 is 24,000 megabits per second. So it has a PC rating of 24,000. But they'll never ask you this on an A+ exam. So you don't need to worry about it. Error check parity. That motorcycle goes by. Detects and corrects errors in a single bit. Can detect errors in 2 bits, but cannot correct it. Parity used by older sims and use error checking based on the extra 9th bit. Odd parity, parity bit to make odd numbers of ones. Even parity, set to make an even number of ones. The parity error number of bits conflicts with parity use. Error checking, ECC memory, is more expensive than regular memory. You see it if you try to buy it on Amazon or Dell. ECC is more expensive. You normally don't want to put ECC in your regular computer, right? Because one, it's more expensive. But if you think about it, the type of computer that you want to have ECC on is servers. Why? Because if you get an error, a memory error, and you get the blue screen of death, usually that's what happens, right? And your workstation, you just reboot. It only affects you. But you need to put ECC memory on servers because if there's an error, it'll just correct it and keep it moving. You don't want 200 people having to tell them, oh, wait, the server crashed, I got to reboot. You don't want that, right? Time is money, as they say in business, right? So that's what you want to do. You want to put your ECC memory in servers, not in your workstations. They're going to cost a lot of money if they're in your workstations. Oh, as you can see here, server memory use ECC for fault tolerance. Let's see what kind of different. Yeah, this is ECC. This is ECC right here. Buffered and registered DIMMs. Buffers and registers hold data and amplify a signal before data is written. Can increase memory performance in servers. Registered DIMM or RDIMM uses registers. Unbuffered DIMM, no buffers or registers. They never ask you about registers in the A+ exam. Column axis strobe latency is a way of measuring axis timing. Reference to a number of clock cycles it takes to write or read a column or row of data off a memory module. Lower values are better than higher. Memory module adds provide CAS latency values between a series of timing numbers. Never ask you on this on the exam. Types of memory used in laptops. Today's laptops use DDR4, DDR3L, DDR3, or DDR2 SODIMM. Only use the type of memory that the laptop is designed to support. How do you check? Manufacturer's website. The number of pins and the position of the notches on the SODIMMs keep you from inserting the wrong module in a memory slot. If it doesn't fit, don't force it. To upgrade memory means to add more RAM to a computer. Adding more RAM might solve slow performance, application refusing to load, an unstable system, or Windows insufficient memory error message. I got more because I knew since we were going to do distant learning, I was going to have a lot of stuff open at the same time. And it was running a little, it was a little slower. So I decided to upgrade. Questions to ask when adding more memory to your computer. How much RAM do I need and how much is currently installed? What type of memory is currently installed? How many and what kind of modules can I fit on my motherboard? How do I select and purchase the right modules? And how do I physically install it? How much memory do I need and how much is currently installed? When deciding how much the memory the system can support, consider the limitations of the motherboard, the processors, and the operating system. Windows 10, 8, and 7 requires at least 1 gig for 32-bit and 2 gig for 64-bit installation. But 2 gigs is nothing. For 64-bit installation, Windows 10 Pro can support up to 2 terabytes of memory. Windows 8 can support 512, Windows 7 192. A 32-bit Windows 10, 8, or 7 can support no more than 4 gigs of memory. This is why most people don't have 32-bit computers anymore. How many slots do you have? Open the case and look what type of memory is already installed. Open the case and look at the memory slots. How many slots do you have? How many are filled? Review module imprint. Examine the motherboard from the imprint manufacturer and the model. Read the motherboard documentation. See if the board supports dual, triple, or quad channels. And if you still have not identified the module type, take the motherboard and all memory modules to a good computer parts store for confirmation. All right, use a label on the DIMM to identify its features. Look for the manufacturer model of a motherboard imprinted somewhere on the board. Read the motherboard documentation. Again, I cannot begin to emphasize how many times you need to keep that in handy, or you could always go to the website. Most motherboard manufacturers have the documentation on the web. Indicates how much memory the motherboard can physically hold. DIMM models. DIMM can be installed as single modules to support dual channeling. Install matching DIMMs in each channel for best performance. Motherboard using DDR3 triple channel DIMMs. Use 3 matching DIMMs in the 3 blue slots. If the 4 slots populated, board reverts to single channel. Dual channel, installing 2 matching DIMMs in 2 blue slots furthest from the processor. Leave the other 2 slots empty. For 1 install, placing the blue slot furthest from the processor. Motherboard using DDR3 triple channel DIMMs. Serial presence detected. DIMM technologies that declares module size, speed, voltage, and data path width to system's BIOS at startup. Today's memory always use SPD. 4 DDR slots on a motherboard. How do I select and purchase the right memory modules? Compromise if the exact match is not available. Mixing unbuffered memory with buffered or registered memory will not work. Match memory module manufacturer if possible. In a pinch, you can use memory from 2 different manufacturers. If mixing speeds, computers always do this, all modules perform at the slowest speed. So if you have one that's 2400 and one that's 1600, it's going to run at the 1600. Use a website to research your purchase. Look for search utilities matching modules to your motherboard. How do I use the critical upgrade utility to correct memory for an upgrade? This is a software, a website, critical.com. How do I install the new modules? Well, again, use the ESD strap, turn off power, unplug power cord, press the power button to drain the power, remove the case cover, handle memory modules with care. Do not touch the edge connectors on memory modules or memory slots. Do not stack cards or modules. Look for notches on one side or in the middle for correct orientation. Install DIMMs, pulling out supporting arms on the slot, on the sides of the slot. Use notches on the DIMM edge connector as a guide. Insert DIMM straight down into the slot. When the DIMM is fully inserted, the supporting clips pop back into place. When the computer powers up, it counts the memory present. You enter BIOS or UEFI to verify that the memory is recognized. Those are the clips that you hold in place. open clip in the empty slot. Like what I like to do when I have my students, if I ever teach a class that we actually have computer parts and I have the students take it, disassemble it, and put it back together, one of the first things that I check is I try to pull the memory out. Because a lot of times either they don't put it right here in the slot or they don't clip it to hold it in place. So I go around and try to pull out the memory. Insert the DIMMs into the slot by pressing down until the support clips lock. Do not force it. You'll break it. Upgrading memory on a laptop is similar to upgrading memory on a desktop. Again, considerations: make sure the warranty is not being voided. Search for a best buy on a suitable and authorized part. General steps: decide how much memory to upgrade, purchase memory, and then install it. Be sure to match the type of memory to the type the laptop supports. And that's it.